Let us now examine this interesting point here where s is equals to minus 1. Our function f of s is equals to 1 over s plus a. And when s is equals to minus 1 is 1 over minus 1 plus a. Our signal of interest is f of t is equals to e minus at ut. And in our signal, a is equals to 1. So the interesting thing about this point when s equals to minus 1 is this. Of course, it's immediately obvious that we have infinity here when s is equals to minus 1 due to a being equals to 1. Now, let us understand from another perspective why fs is equals to infinity here. We have the signal of interest f of t equals to minus 1. Sorry, I mean to say f of t equals to e minus 1t. Now, let's study this Laplace equation here, which is integrate of 0 to infinity, because we are in the unilateral Laplace transform. We have f of t e minus st dt. Let's substitute s is equals to minus 1 here. So when s is equals to minus 1, basically we have e plus 1t. What about ft? Ft is e minus 1t. Together, e minus 1t multiplied by e plus 1t, we get 1. So this equation becomes integral from 0 to infinity of 1. Therefore, of course, this is infinity. So this is another way to look at why this is equals to infinity. It is also, what do you call that? It is also educational for us to see e minus 1t and e plus 1t. And when they multiply each other, they become e to the power 0t. This is e minus 1t here. It decays as time goes from 0 to positive infinity. What about e plus 1t? As time goes to infinity, it actually becomes larger and larger. But when they multiply with each other, e plus 1t and e minus 1t, they become e to the power 0t. So this is a function that is 1 continuously. The Laplace transform, which is integrating this final product of these two exponential, is integrating 1 from 0 to infinity. Then of course it goes to infinity. So this is one way to understand why when s equals to minus 1, we get infinity for f of s. Right. Finally, the last slides for this part is talking about existence of Laplace transform. Not all signals are Laplace transformable. However, if the function f of t is of exponential order, that means the absolute value of this function is less than some constant multiplied by some e to the power ct, where ect is some exponential, and it can be ect can be growing, right? But as long as this absolute value, when it divided by some constant ect, tends to 0 and the limit exists, then we call this ft is exponential order. And for all exponential order function f of t, the Laplace transform exists. Okay, so examples of signals that are not Laplace transformable is t to the power t, e to the power t square. I mean, we're talking about with respect to the unilateral transform here. Okay, thank you.